the next stage of what's happening with this, which is going to be solving by factoring. Okay, as I said, we are going to be we're going to solve trig equations by factoring. And that's yay, because I know how much everybody loves to factor. So when we add doing all of the problems that we have with this, it's going to be great fun. I'm absolutely certain of that. So the good news would be you do things the same way that you would do under normal solving, okay? So like if I had this equation, 2 sine x cosine x is equal to sine x, and I want to solve this. I want to think something that I understand a little easier. So 2xy equals x. Same kind of problem. Now I know the first thing you want to do in this scenario right here would be that you want to divide by x, but don't do that. You can never divide out x or a function. So you move it over to the other side. So 2xy minus x equals 0. Then you would factor what they had in common. So x times 2y minus 1 equals 0. Then you would set each piece equal to 0. And then you would solve each piece. So the same is going to work for this one. I'm going to move sine over to the other side. So 2 sine x cosine x minus sine x is equal to 0. Factor out what they have in common. They both have a sine. So so factor out the sine. So sine x times 2 cosine x minus 1 equals 0. Set each piece equal to 0. Sine x equals 0. 2 cosine x minus 1 equals 0. Where is sine equal to 0? So x would equal 0 in pi. 2 cosine x, so cosine x equals 1/2. I'm okay with you doing mental math with that. Where is cosine equal to 1/2, which would be here and there. So for this one, x is equal to pi over 3 and 5 pi over 3. So if I ask you for answers in 0 to 2 pi, you would tell me 0 pi, pi over 3, 5 pi over 3. If I said, what would it be in all real numbers? It would be x equals pi k, so that would be 0 to pi. And then x equals pi over 3 plus 2 pi k, and x equals 5 pi over 3 plus 2 pi k. That's another problem. So if I were to have 2 cosine squared x minus cosine x is equal to 1. All right, so thinking about what I would have had before, that's like saying 2x squared minus x is equal to 1. We know that anytime something's quadratic, it needs to equal 0. So 2x squared minus x minus 1 equals 0. And then somehow you do your factoring, whatever method you choose, whether it's this, whether it's the x method, I don't really care. So however you factor, I can do the same. So I'm going to do this. So move 1 over. So 2 cosine squared x minus cosine x minus 1 equals 0. So I'm going to factor like I factor. So 2 cosine squared, the only way I can get that is to say 2 cosine x times cosine x. 1 is 1, 1. I need a negative 1, so 2, 1, so this is negative and this is positive. But again, however you factor will work. Now set each part equal to 0. 2 cosine x plus 1 equals 0. Cosine x equals 1. Or 2 cosine x equals -1. Cosine x equals -1/2. Where does cosine equal -1/2? So -1/2 would be there and there. So x is equal to 2 pi over 3 and 4 pi over 3. X is equal to 1 at 0. So if I wanted 0 to 2 pi, I would have x equals 2 pi over 3, 4 pi over 3, and 0. If I want all reals, you would say x is equal to 2 pi k, because I can only do 0 this time. And x is equal to 2 pi over 3 plus 2 pi k. And x is equal to 4 pi over 3 plus 2 pi k. Just another format of factoring. So 2 sine squared x cosine x minus cosine x minus 2 sine squared x plus 1. And I know that looks super scary as you look along the way with that, but think about this one. I have 1, 2, 3, 4 parts. So anytime that you would have something that had 4 parts on it, that would be factor by grouping. So what do those have in common? What do those have in common? So looking at the first two, they have cosine x in common, which leaves me 2 sine squared x minus 1. The second group has a -1 in common, which leaves me 2 sine squared x minus 1. Which is awesome because those are the same, which is what they need to be in factor by grouping. So cosine x minus 1 times 2 sine squared x minus 1. So each part, so cosine x equals 1. Sine squared x is equal to 1/2. So x is equal to 1 at 0. And then when I do this one, remember you square root. So that's going to give me the sine of x equals 1 over root 2. And because I input the square root there, it is plus or minus. And we remember as you're doing this one, think about that as the square root of 2 over 2. So x is equal to square root of 2 over 2 are the pi over 4s. So pi over 4 and 3 pi over 4 are the positive ones. 5 pi over 4, 7 pi over 4 are the negative ones. So if I was looking for 0 to 2 pi, it would be x equals 0 pi 4, 3 pi 4, 5 pi 4, and 7 pi 4. If I want all real, then you would have x is equal to 2 pi k, or x is equal to pi 4 plus pi half k. That would be the shortened version of what you would be doing with that. So if you want something that's not the shortened version, you can use all of that. So for the last one, you can have the cotangent of x minus the cosecant of x plus the cosine of x is equal to 1. So I want you to think for a second, what is going to be the first thing you should do if you are going to work this problem. Okay, so subtract 1. Because if I subtract 1, I have it equal to 0, which is where I want everything. Okay, then you said make things equal to sine and cosine. So if I said cosine x over sine x minus 1 over sine x plus cosine x minus 1 equals 0. Okay, so that one, I'm thinking through the part that goes along with that. Now I look and go, this is really creepy, but I have 1, 2, 3, 4 parts. So therefore, this is going to be a factor by grouping problem. What do the first two have in common? What? Cosecant x or 1 over sine x. So if I factor out, we'll do 1 over sine x for the people who aren't seeing this cosecant part. So that leaves me cosine x minus 1 plus 1 over cosine x minus 1. And then 1 over sine is cosecant. So that leaves me cosecant x equals -1 and cosine x is equal to 1. Okay. Cosecant goes with sine, so flipping it says that's the same as the sine x equals -1. Sine, so x equals -1 at 3 pi half. And cosine x equals 1 at 0. So I would like to caution you and say you need to always check an equation with tangent, cotangent, secant, and cosecant functions for undefined values. Okay, because all of these functions have an asymptote. And because they do, I need to know where the asymptote falls for this. So I have cosecant, and the domain of cosecant is x cannot equal pi k. Well, that means that 0 is not going to work because that would be undefined. So this would be an extraneous solution. So the only answer that works this time is x is equal to 3 pi over 2. And think about that. If cosine is 1, sine is 0. If I have sine in the denominator, it cannot have a value of 0. So just to remind you, if you have tangent x or secant of x, the domain for that is all real, but x cannot equal pi half plus pi k. If I have the cotangent of x or the cosecant of x, that domain is all real, but x cannot equal pi k. So if you come into one of those, that would make undefined values, right? So those are the undefined values that you are going to be looking for.
Mr. Sherry, question. On the previous